Hello, today we are going to look at 30, 60, 90 triangles. Personally, one of my favorite lessons and concepts that we come across in geometry. Previous lesson, we looked at another type of special right triangles, that being 45, 45, 90. Saw that all of those kind of triangles are similar, so they have a similar ratio with each other. And we're going to kind of explore a similar concept today with our 30, 60, 90. So if I look at the problem that has in front of me, it wants me to analyze our triangle. It tells me that that this is an equilateral triangle. It tells me I have an altitude, and it gives me the side length of one of the sides, that being AB. So I have an equilateral triangle, so let's start with that. If I have equilateral, that means all of our sides are equal, of course, which means all of our angles are going to be equal. In this case, it being a triangle, it will be 60 degrees, and all of our corners. Even up here would be 60, but if you notice, we have an altitude here, CD. So you could probably guess what that altitude is going to do to that 60 degrees is bisect it. So each side, we're going to get 30 degrees. So of course, when we add that up, we get 60. And then of course down here, where that altitude hits the base, that is going to be perpendicular, making a 90-degree angle. So I got the angles taken care of, and it tells me that AB down here is 2. So if AB is 2, that means that CD right here is going to be 2, and then CB is going to be 2 as well. These individually are going to be 1. So start with an equilateral triangle. I've dropped an altitude, and now as you see, I have two 30, 60, 90 triangles. Thus we get the term from it. So like what we saw with the 45, 45, 90, we had a ratio that goes along with them. We notice that they're all similar. It's going to be the same case with our 30, 60, 90. So all 30, 60, 90 triangles are similar. So if I look at my sides of one of my triangles, so let me get a different color right here. So if I just isolate our triangle here that I have in green, so there's my 30, 60, 90 right there. I have this side length down here. This is actually my smallest because it's opposite from the 90 is 1. I have my hypotenuse is 2, but I don't know what this CD is. So we can easily figure out what that's going to be. If I have a right triangle, we should be thinking about our best friend in geometry, that being Pythagorean theorem. So a squared plus b squared equals c squared. So if I plug in what I have, let's say that I'm going to call CD a squared plus 1 squared equals, that's an equal sign there, 2 squared. So I'm going to get a squared plus 1 equals 4. So I can rework that around and get a equals the square root of 4 minus 1. A equals the square root of 3. So I know that my altitude, or my height, you can even call this, of my triangle, is going to be the square root of 3. So I have one side being 1, my short side. I have my longer side right here being the square root of 3, and then 2 being for the hypotenuse. So over here, we're going to look at our official ratio. Let me get a different color here. I'm going to go red because it's important. So I'm going to have my right angle. Might help if I have a smaller font there. We'll go with this one. So I have my 90 degrees right here. I'm going to put 30 degrees up top, 60 right here. So everything goes through our short side. Call that X. So we have to go through there. That was 1 over here. You should notice that going from 1 to 2, I doubled that. So the ratio between the short side and the hypotenuse is going to be 2x. So if this was 5, then that would, of course, be 10. It's always going to be double. And then we have our long side. Notice I didn't say the longest side because that goes to the hypotenuse. But our long side, I just have our radical 3 there. So remember, in front of every radical is the imaginary number 1. So this is going to be x to radical 3. So right here that I have in this box, that is going to be your important ratio. Like I said, all of these are similar. So by knowing this, I can solve for any side. And of course, if I plug each of these into Pythagorean theorem, our x radical 3, and our 2x, they're actually going to equal each other, which I think is pretty neat. So I plug that in. So I got x squared plus 2 radical 3 squared equals, it's going to be 2 squared. So if I solve this down, we get 3 squared equals 4 squared. We're going to see that those two equal each other. So 4x squared equals 4x squared. So that's the neat thing about 30-90 or 30-60-90 triangles. But here's our ratio right here. So we're going to work a few problems out in a second. All right, so let's work a few problems out. One thing that you can do, or that I like doing, is making a little chart with each of these. So what that looks like, I know I have my 30, I have my 60, and I have my 90 degrees. So what goes with my 30 is just x, because that's my short side. Our hypotenuse is 2 times that. Then we have x to the radical 3. So if it helps you to label each side, you can do that. So if I know that this 10 is going to be my hypotenuse, I know across from my 60 is going to be my long side, and then my a, because 30 degrees is going to be here, will be my short side. So I need to take a look at what I have. So in this case, in each case, they're going to give me one number. In this case, they give me the hypotenuse. So my hypotenuse, which is across my 90 degrees right here, is 10. So one thing that you're going to notice is that it's going to be easiest to go through our x. Everything goes through this short side because we can get to the x a lot easier. Going from 2x to x squared root of 3, it is possible that it's easier to go from 2x to x. So if I have 10 for 2x, then that means that x right here has to be 5. So when I multiply that by 2, I get my 10. And then once I have x, you'll see it's pretty easy to get my 60 degrees. I just got to slap the radical 3 behind it. So right here is going to be my final answer. So that's all I got to do there. So that means that a is going to be 5, and then b right here will be our 5 to radical 3. So that's how we have to solve these problems. Not too tricky when they have whole numbers, but let's look at one where they give me a radical. So I'm going to go make my little chart right here. So again, in this case, they give me the hypotenuse right there. Here's my 30 degrees, so here's my short side, and here is my long side. So I have 2 radical 3 right there. So to figure out what 30 degrees is, it's going to be half of this 2 radical 3, so that's just going to be radical 3. And then for my 60 degrees, if you notice, I got x radical 3. My x is radical 3, so radical 3 times radical 3, you can plug that into your calculator, or you can easily see that that's going to equal 3. Those two radicals essentially cancel each other out. So in this case, g is going to equal 3, and then h is going to equal radical 3. And then our last one over here, so I got 30, I got 60, I got 90. So again, making my chart. Alright, so here's my 30, so y is going to represent my short. Here's my long side over here, and here is my hypotenuse. So once again, they gave me the hypotenuse. All these 3 problems they did, not usually the case, I'll mix it up, and we'll see those in some other problems. So I got to figure out what my x is going to be. So it's going to be half of that. So it's easiest if you keep this as a fraction, so I can just write this as 5 radical 3 over 2. There's no need to divide that 5 and 2 and get 2.5. It kind of looks ugly that way, so it looks a lot nicer when you keep it like this. And then I got to multiply that times radical 3. So I'm going to clean a little bit of this up so I got some room where I can do this math, but I got 5 times radical 3 over 2 times radical 3. So these radical 3's, just like what we saw right here in the problem before, is going to become 3. So in essence, what I get is 5 times 3 over 2, which is 5 over 2. And the 5 over 2, we can either keep that as a fraction or make an easy decimal of 7.5. So 7.5 is going to represent my long side, which in this case is x, and then my short side right here is y. So this is how we work these problems. We saw one out with a whole number, not too actually the easiest as it will get. We saw 1, or we see 2 right here. with radicals, so we just got to know our rules with radicals. We should be familiar, especially with last lesson in the bell ringer, we covered that. So all these other problems we should be able to handle ourselves. I want you to pause this video right here and do 1 and 4 through 6. I'm going to have it already worked out and then just explain my math through it. I'm not going to go through and do all my math just to save time. So pause right now, work 4 through 6, and then I'm going to talk about those. All right, so here is 4 through 6. So number 4, they gave us the short side this time instead of the hypotenuse like all the problems before. They gave me the short and told me that it was 4 radical 3. So going from there, I could have gone to either get my hypotenuse first or my long side. Doesn't matter because the short side represents x. Probably the hypotenuse is the easiest one to get. You just got to multiply that by 2. So the 4 by 2, and you get 8 radical 3 right there on that one. And then, so we get that right there. And then to get our 60, I'm going to go 4 radical 3 times radical 3. So those radical 3s, as we've seen, they become the whole number 3, so that's where we get this 12 from. And number 5, this time we have it in a different medium. So it's basically two 30, 60, 90 degree triangles, but they're mashed together where we end up getting a rectangle from it. So even though we have a rectangle, we still attack it like it's just a regular problem. So look, they give me the short side this time of that being 5, so I get that right there. So getting the hypotenuse, or I can go either one, doesn't matter, but the hypotenuse is pretty easy. That's going to be 10 because that's going to be double that, and then the long side, you just got to slap radical 3 at the end of it. When we look at 6, this is the first instance where they give me the long side, and I got to go and get my other side. So the long side could be it's probably the trickiest one that we get, and you see that with our short side. So our long side is x radical 3, our short side is x. So to get from x radical 3 to x, I got to divide by radical 3, and that's what I got going on right here. So if you remember, you can't have a radical on bottom. The reasoning behind that's with a radical, you're going to get a whole number that goes, or you're going to get a decimal, that goes on forever, and you can't divide by a number that goes on forever. So we have to conjugate it or multiply it by itself to end up getting a simpler form of that. So 12 over radical 3, that's not mathematically correct. That's not going to be a number. You can plug that in your calculator and you'll get a number, but that's going to be an estimate. So you're multiplying that by radical 3 over radical 3. So on top, you're going to get 12 radical 3. Then on bottom, you're going to get radical 3 times radical 3, which gives you the whole number 3. Then we have 12 over 3. So this right here is technically an acceptable answer in the sense of it's not simplified all the way down, but we can plug that in and we can get a number from that. But we can reduce that 12 and 3 and get 4 radical 3 there. And that's going to be our simplified final version. 12 is going to be right here for 6, and then that 90 degrees, our hypotenuse, I just got to double this, and I get 4 radical 3. So that's how those 3 problems are worked out. So with the next 4, 7 through 12, you should be able to do those. So once again, I'm going to do the same thing where I want you to pause. I want you to work 7 through 12, and then I'm going to have the work already out on screen so you can check your answer to see if you got the same thing as I did. All right, so here is the next 4. That's all I can fit in the screen. I'll look at the other 2, having 11 and 12 after these. So looking at number 7, I got an equilateral triangle, kind of like I had in when I was setting this entire thing up. But we got 15 that represents our hypotenuse. So I have to divide by 2 to get my 30 degrees on my short side, which is going to be right here. Or in this case, x. They have it over there as well. So I could get a decimal there of 7.5, but it's easy to keep it as a fraction. So when I go and get my long side, that being our x radical 3, I try to slap that radical 3 in the numerator and then be done. I don't want to keep that as a decimal and say 7.5 radical 3. That doesn't look nice as this. So we get our 15, divide by 2, keep it as a fraction, put that radical 3 in there. Number 6, we have our long side, that being 16. So to get to my short side, just like we saw in problem 6, we have to divide by radical 3. So we're going to conjugate it, and we get 16 radical 3 over whole number 3. But if you notice, this won't reduce down, so we're going to keep it like this. So just like this problem before, we're not going to get a decimal and put a radical at the end of it. We're going to keep it as a fraction. So not all the time is it going to work out where when we go and conjugate it, it's going to get a nice whole number. Then our radical, we're going to get a fraction. So we have that right here for a short side, and then to get to our hypotenuse, we got to multiply by 2. So that 16 is the only thing that ended up multiplying by 2. So I get 32 radical 3 over 3. Number 9, they give me the short side. So to get to my long side, or actually hypotenuse is easiest. To get to my hypotenuse, all I got to do is multiply my whole number by 2. So kind of treat that radical kind of like a variable, kind of like you were solving for pi, where you treated pi like a variable. Kind of same concept here. Multiplying that by 2, you get 24 radical 3. And then to get our long side, I need to multiply by radical 3. And this is something that we'll be very familiar with because you're going to work it a lot with 30, 60, 90. But radical 3 times radical 3 is the whole number 3. So 12 times 3 gives me my 36 there. And last one, number 10. I really like number 10. Makes us think a little bit. So we have a trapezoid here, just kind of turned on its side. But if I draw a line right here, I can see that I got a 30, 60, 90 triangle because I'm going to get a right angle there. Then that makes 30 degrees right here. So this line that we drew right here, that's going to be the exact same as the 6 radical 3. So that's the number that we get in our situation. So I just got to pull that down right there. That's going to be my long side right there. So to get my short side, I got to divide by radical 3. That works out to be a very nice whole number of 6. And then to get my hypotenuse right here, I just got to multiply by 2 and get 12. If you notice, I haven't solved for everything. I still got this y right here. So y is not attached to this triangle. It's attached to one of the bases of the trapezoid. But if I think about what I have, this entire thing right here is 21. And then if I see my short side right here is 6. And that's what that y is missing. So y is going to be 21 minus 6. And that gives me 15. So y equals 15. All right, so let's take a look at our last two in this little work set, and we'll look at 13 and 14 together. So for 11, we have a parallelogram, but if you notice, we got 60 right here, we got 45 here. So we have to combine what we learned from last class with what we're learning now. So I can split this into two triangles right here. So if I look, this 9, 2 squared, or 9 radical 2 is going to be the hypotenuse of my 45, 45, 90. So to get my other sides, we should know this pretty easy. We have to divide by radical 2, which is going to give me the whole number 9. So if this is 9 right here, that means across the way, this is also going to be 9. That 9 represents the long side, like I have here. So I need to get my short side first. So to do that, I'm going to divide by radical 3. And then because I have radical on bottom, I need to conjugate. So all of this math leads me to 3 radical 3 as my short side, which is right here. And then to get x, which is the goal of this problem right here, I have to just double that. So the easiest part of this problem actually is just multiplying that by 2 and getting your 6 radical 3 as your final answer for x right here. So combining two things that we should know how to do, our 45-45 and our 30-60. We're going to keep that same energy going into number 12. So a lot of different numbers I got to solve for, A, B, C, D right here. I got 30, 60, 90, 45, 45, 90. Don't think that for some reason up here, like that's not going to be a right angle. So don't think that that will be, because obviously 60 plus 45 is not going to give you 90. That's going to give you 105 there. So if I look at the problem that I have, it gives me one number, which is 12, which represents the long side of my 30, 60, 90 triangle. So if that is 12, then I need to divide by radical 3 to get my short side, which is going to be 4 radical 3. I've done this 2 times, I believe, already in previous problems, so we should kind of know what we're doing there in terms of conjugating it, simplifying. We get 4 radical 3 as our short side, and then to get to our hypotenuse, pretty easy. I just got to double that 4, make it 8, so 8 radical 3. So that takes care of A and C. Now I need to worry about B and D. So if I notice I got a 45, 45, 90. So if I got 4 radical 3 right here for A, D, the other leg of this triangle is going to be the exact same. So I think I have that actually switched. Let me switch that right there. There we go. So D equals 4 radical 3. And then to get B, which is the hypotenuse of my 45, 45, 90, I got to multiply by radical 2. And here's my math here. 4 times radical 3 times radical 2 gives me 4 radical 6. And 4 radical 6 is going to be my hypotenuse there. So that's how you work those two. Let's go look at 13 and 14 and look at those together. I do want you to try them, but I'm going to work them out, explain my thought process or the process of going through each of those. All right, so looking at 13, it wants me to calculate the area of the regular hexagon. So if you remember, our area formula for this is 1/2 small a, which represents the apothem, times the perimeter. So I don't know what the apothem is yet. I should know what the perimeter is. I have a hexagon, regular hexagon, so all the sides are the same. 2 being one side, so 2 is going to be on the other side. So 2 times 6, big brain math, that's going to give me 12 right there. So I'm going to kind of divvy this up, create our different slices, or technically rectangles there. So first thing I need to figure out is what my central angle is going to be. So I got 360 degrees. I have 6 of those, so divide that, I get 60. So each of these right here represents 60. So from there, I'm going to need to figure out what my apothem is. So I'm going to get a different color in here so this isn't just a bunch of black dots. But here's my apothem right here. I'm going to focus in on this triangle, which represents half of one of those slices there. So I know I got 2 on the bottom. I'm looking at half of it, so 1 is going to represent our side length right there, our short side. And then I have a bunch of equilateral triangles. So because this is a regular hexagon, we get our equilateral triangle. So that means that 2, if it's here, it's going to be right there for the hypotenuse. And then this is the side that I don't know. I'm going to just call that x right now. But I should see that what's going to happen is I got a 30, 60, 90, because like I said, these are all equilateral. I know I got 60 as my central angle, half of that being 30. So I should be able to figure out that if this is my short side, this is my long side, then the side that, or I'm sorry, this is my hypotenuse. My long side is going to be this radical 3. And that radical 3 is what my apothem is going to be. So switch my colors, so there we go. So I got 1/2 radical 3 times 12. So once I simplify all that down, I'm going to keep that radical 3 out there and get 6. So 6 radical 3, my unit here is feet, so that's going to be feet squared. So this will represent the area of my hexagon. Okay, and then in 14, wants me to derive the area formula of an equilateral triangle. So this one I really like, making us think a little bit, combining some stuff that we know. So we know that for a regular triangle, it's going to be the base times the height, but if you look in this situation, I don't know what the height is going to be. But I know that this is an equilateral triangle, so I know if I have S here, then I got S over here, then this entire thing down here is going to be S. Is going to be S. Kind of funny there, BS. Anyway, so I'm going to drop in a apothem down right here. There we go. There's my 90 degrees. So I can see that I got 60s in the corners and then 30 up top. I know that this side right here, or each of these sides are going to be equal, and put 2 tick marks to show that this is going to be 1/2 S, 1/2 S. So S, of course, representing our side length. So I can get all the sides with my 30, 60, 90 triangle, knowing my rules. So my short side I know is 1/2 S. My x radical 3, which is going to be the altitude, I'm going to multiply that times radical 3. So I'm going to get radical 3s over 2. And then lastly, my hypotenuse right there is s. So that's all of my sides. So I had 1/2 s. So when I multiply 1/2 s times radical 3, that's just going to be radical 3s over 2. And then, of course, s represented there. And then, like I said, our area of a triangle, 1/2 base times height. So if I kind of write in what I have, I got 1/2. My base in this situation is just going to be s, because 1/2 s plus 1/2 s is s. My height is going to be this nice, beautiful radical 3s over 2. So then from here, once I combine all of my like terms and everything, I get s times s, which is s squared, and then I got radical 3 left. So my area formula, I got my radical 3 times s squared, and then that's going to be over 2 times 2, which is 4. So this is going to be my area formula of an equilateral triangle. So if you Google that, area formula of an equilateral triangle, you'll see this equation here, and it comes from our 30, 60, 90 triangle, which I think is pretty neat. And then down here, it wants us to use this formula, so I don't know why I cut off on 2 pages, but I'm going to just show my work over here. Let me get a different color on here. Let's go green. Using that formula, it wants me to calculate the area of the regular hexagon in number 13. So we should see that a regular hexagon is made up of 6 congruent triangles, or equilateral triangles, so equilateral triangles right there. So I'm going to use my formula, but because I have 6 of them, it's going to be 6 times this formula. So, like so. So, S represents my side length. I should see that my side length is right there. That's going to be 2. So, I'm going to have 6 times radical 3 times 2 squared over 4. So, I've got 6 radical 3 times 4 over 4. Obviously, these 4's are going to cancel, so I'm left with 6 radical 3 feet squared. Can't forget the units. And if I notice, that's the exact same thing I got right there. So just another way to work that regular hexagon problem. I get the exact same. So that will wrap up our notes for our 30, 60, 90 triangle. So we should have a pretty good grasp and understanding of this special right triangle. It's a little different from our 45, 45, 90 in the sense of there's a little more steps, not 2 of them, like the 2 legs aren't the exact same like you get with the 45, 45, 90. Hopefully have a good understanding. Go and do the assignment, extra practice, get some more practice, get some more feel for this. And that will be it for our notes.